This video is on gas chromatography and liquid chromatography. Your sample, whatever it may be, is diluted and injected into a gas chromatograph or liquid chromatograph. The data that comes out looks like this and is referred to as a chromatogram. It is your time towards your absorbance, and you will notice that some peaks will appear. Think of this as a TLC plate on its side, and those peaks are your spots. As long as your conditions remain the same compound will appear at the same time. The flip side of this is that the chromatograms are useless if you have no standard to compare them to. So if you don't know what appears at 5 minutes or at 15 minutes, this is just telling you that you have a sample with two things in it, but that's about it. There is a reason why this system is probably the most common system to be used in all of the chemical industry, because it is useful for purity control and quality control. The areas of the peaks give you the purity. So assuming that the combined area is 100, and if in this case the area of this peak is 70 and the area of this peak is 30, it means that our sample is 70% pure with respect to this compound, with an impurity of 30% of this other compound. The most common thing to combine liquid chromatography or gas chromatography is with mass spectroscopy, with instruments even being called GCMSs or LCMSs. These instruments are really useful because they will tell you what the mass of the compound is that is causing the peak to appear, and of course all the fragments too. So for example, if we had a standard of menthol and we know that menthol appears at 5 minutes, we could say this is a 70% solution of menthol with an impurity. However, with the mass spec combined with it, we can confirm that it's menthol by its mass and then identify what the mass of the compound is at 15 to be able to figure out what it is.